BlueCube systems provides real-time inline mineral analysis. This includes mineral analysis, elemental analysis, particle size, as well as percentage solids. So how is this done? Let's start by looking at the physics of light. On the longer wavelengths we have the radio frequencies, and then on the shorter lens we have the very short frequencies, gamma rays. Where BlueCube systems fits in is we're looking at the visible and near visible spectra. We do this using a technology called DRS, or diffuse reflective spectroscopy. Other well-known technologies used in the mineral industry is XRF and XRD. These ones look at a very narrow range, requiring longer integration times, while the visible and near visible range require shorter integration time and cover a wider range. So how are we doing this? By shining a light on an upward flowing slurry. The reflected light is then passed back to a spectrometer, which digitizes it and makes it available for further modeling. Let's talk about the main BlueCube idea. And this idea is used to address one of the biggest problems in the mineral industry. A typical mineral plant or mineral process plant requires a sample to monitor or control the process. This sample can be taken every few hours, on a shiftly basis or on a daily basis. And the time it takes to analyze this result can take from a few hours to a few days. And this is the problem that BlueCube wants to address. We want to provide the plant with real data that they can make informed decisions right now when it's needed, not after the fact, when it's too late to act. So how do we do this? What we do is we install an inline pneumatic sampler that takes automatic samples. This sample is then synchronized with the spectra that the analyzer measures every 15 seconds. So when the sample is taken, we match that specific sample with the specific spectra that was taken at the same time. This sample is then collected at least on a daily basis by the plant, and when the results becomes available, those results are then sent to BlueCube. BlueCube then uses the analysis to match it with the spectra and then create a model that enable us to give a real-time output to the plant to use to control and monitor the process. So let's look at how this is implemented on a real plant. We have a slurry stream. This could be a tailing stream, a feed stream, a concentrate stream. Typically, the BlueCube spool piece is installed on a vertical upward flowing slurry. So in the spool piece we have two interfaces. One for the BlueCube scannet that is used for the light that is projected onto the slurry and then captures the reflected light that passes back to the optical processor. The second is for the inline pneumatic sampler that is used to take the automated daily sample. The spectra captured by the optical processor is then sent to the data processor. The data processor uses the model to then output real-time data to the plant. At the same time, and especially for the samples that was taken by the inline pneumatic sampler, the spectra from these samples is transmitted back to the data centers of BlueCube, and once the analysis from the lab is sent to BlueCube, these are then matched and downloaded onto the equipment. This process of updating the model is repeated at least every 2 weeks, and our requirement from the plant is to receive or at least allow for the taking of one daily sample. In a real example, this is the spool piece where the slurry flows vertically. Then we have the scannet that is used to transmit the light onto the slurry and capture the reflected light that is then passed back to the optical processor. On it as well is the inline pneumatic sampler. Then next to the optical processor, we have the data processor that uses the spectra from the optical processor and the model that has been downloaded onto the system to calculate and send the real-time data to the site. Also from here, the spectra is transmitted back to our offices and data centers. One of the main benefits of the BlueCube analyzer is it can measure both light elements and heavy elements. So in industries like the iron industry, the BlueCube analyzer can measure both iron and silica. If we look at the gold industry, we can measure sulfur and silica, but also iron, copper, arsenic and gold. And then added to that, we can also measure physical properties like percentage solids and particle size, all in the same equipment. Added to that, the equipment doesn't require big infrastructure changes to site as some other products require. And lastly, the equipment provides safe operation. It doesn't use X-rays, there's no nuclear sources or even lasers. BlueCube believe that our equipment addresses some of the major issues or problems that a lot of sites do experience. We have offices all around the world, and we would value the opportunity to speak to you about how our products could address your needs. Thank you for the opportunity.